So these are the doubts from May-June 2021 paper. The first question is, we have 2.56 gram of a metal oxide is there, which is having a formula of MO2, and it is reduced to 1.92 of the metal. What is the relative atomic mass of M? So what is the mass of a metal oxide? The total mass of a metal oxide, that is 2.56 grams. And out of 2.56 gram, they mentioned it is reduced to 1.92. So what is the mass of the metal itself? It is 1.92. So what will the mass of oxygen? How we work out the mass of oxygen? We just take a difference to know the mass of oxygen. So 2.56 minus 1.92, that is 0.64. So 0.64 grams will be there. That is the mass of oxygen. And how many moles of oxygen will be there? Because if we have the mass in gram, we can get the moles. That is 0.64 divided by mass of oxygen. That, like, to get the moles of oxygen molecule, we divide by 32. Because O2 is there, so it will be 0.64 divided by 32. So 0.02 mole. These are the moles of oxygen. And as you can see, if we have one metal oxide, MO, it will break down into one metal or atom and one oxygen molecule. So as you can see, the ratio, when it will dissociate, it will produce one metal atom and one oxygen molecule. So if there are 0.02 moles of oxygen molecule, how many moles will be there for the metal? That will also be 0.02, because the ratio between them is 1:1. Like when it decomposes, it will give one metal atom and one oxygen molecule. So ratio between them is 1:1. So if 0.02 moles of oxygen are there, there will be 0.02 moles of metal will be there. Now we have the moles, we have the mass, so we can find the molar mass. So we have the formula moles equal mass in gram divided by molar mass. So moles are 0.02, mass in gram is 1.92, and the molar mass we don't know. So it will be 1.92 divided by 0.02. So 1.92 divided by 0.02, that will be equal to 96. So B will be the right answer. So first what we did, we have the mass of metal oxide, we have the mass of metal. So we found what will the mass of oxygen. And then we find the moles of oxygen, and moles of oxygen will be same as moles of the metal, because the ratio between them when it dissociate or break down, it will be 1:1. Is it clear? Discussion?
Yes, sir.
Okay. Can we get relative molecular mass using a formula pure element divided by impure? If the question, the percentage is given, then you can use that formula, but not here. In this question, the four statements about effect of increasing a temperature. If you increase the temperature, the activation energy become lower. Activation energy can only be affected by catalyst. If you use a catalyst, then the activation energy will be lower. The particle will move faster. That's true. If you increase the temperature, the particle will move faster. There will be more collision between the reactant particle per second, means the number of the collision will increase. There will be more collision which have energy greater than activation. That's also, like, greater proportion of the particle will have energy more than activation. That's also true. That's how we write how the temperature affect the rate of reaction. Particle move faster, there will be more collision, and there will be greater number of the particles which are having energy more than activation energy. So there are more collision or more particles, collisions will be there, which are having energy greater than activation energy. That's why C is the right answer. Yeah, 4 means same like about the particle. Like there are more collisions which have greater energy than activation, or there will be more particles which are having energy more than activation. In which equation the underlying reactant is acting like a base? What is the definition of a base? Base is a proton acceptor. So first what happened? CH3CO, acids are proton donors, bases are proton acceptor. So according to this equation, this is donating proton, so it is acting like an acid. And this is accepting proton, so it is acting like a base, so it cannot be A. When you check option B, NH4 and OH, then it becomes NH3, so means this is donating proton. So ammonium ion is there, because the question is in which equation is the underlying reactant acting like a base? Base is a proton acceptor. So NH4 become NH3, so it means it is acting like an acid. Acid are proton donor. 4 become 3, so it donated. So it's not correct. Then we have H2O become H3O, the underlying substance. So means the number of the proton increase. So means this H2O is acting like a base, and CO2 is acting like an acid because it accepts. Here H2O is there. Isn't C4 hydrogen? No. It's, we don't check the overall number of hydrogen. We check for a molecule. Like H2O, there are 2 molecules of water, but we don't say 4 hydrogen. We just check each molecule, how many hydrogens are there. We check the change in each molecule, not total number of the atoms. Because total number of atoms should be same. So when you check here, this one is 2 multiply. You don't say 2 multiply, you will say 2 hydrogens are there in this one. And when it form a product, it form H3O. So how many hydrogens are there? 3 hydrogens. So in terms, it means it has accepted proton. So when it is accepting proton, it is acting like a base. And then H plus is there. It become H2O. So H plus, like this particle, acids have proton donor. So H plus shows that the substance is acid, and OH accept protons, so both will form water. So this H plus is actually an identity of an acid. Why C is the right answer? Because when you don't check the total number, you don't check like 2 multiplied by 2, 4. You will check individual each molecule, how many hydrogens are there, and then check where if it increases means it accepted proton acting like a base. If it decreases, it means it is acting like an acid. Is it clear?
Yes, sir.
Look, in this case, when we break down this equation into 2 parts, we have CO2, we have 2 water molecules, we have H2O, and there is another H2O. And as a result, it becomes H3O plus, and it becomes HCO3 minus. So what actually happened, one of the water molecule donated what? This donated hydrogen to one, that's why it become HCO. And it donated OH to another, it will become SCO, H3O. That is what happened in terms of breakdown. So these hydrogen, this hydrogen, and this hydrogen actually are coming from one of the water molecules. So main idea is that whenever a question is there, identify substances acting like an acid. Acid is a proton donor. So you will check, like example, HCl is there, becomes Cl. So you just check individual molecule, the change. If the proton number, hydrogen number decreases, it means it is acting like an acid. And same thing, H2O was there, it become H3O. So the hydrogen number increases, so it is acting like a base as it accepts proton. Ammonia is made by reacting nitrogen with hydrogen in the Haber process. The equation for the process is shown. N2 plus 3H2 gives 2 NH3. Which change in the reaction condition would produce a greater yield? Yield means like we want to shift the equilibrium towards right. So shifting of equilibrium can only be done by changing the concentration, by changing the temperature, or by changing the pressure, which is only valid for gases. Only 3 conditions can shift the equilibrium. Rest can only, and 5 conditions can alter the rate of reaction, like catalyst is there, addition of a catalyst, or the surface area. If we add more iron, what it will happen? The rate of the reaction will be faster, but it won't affect the yield. It will not shift the equilibrium towards right. It will affect the rate of the reaction. Increasing the reaction pressure. If we increase the pressure, equilibrium will shift towards side where number of moles are less. So in this case, it will shift towards the right-hand side. So what happened to the yield? The yield will increase. Rate will also increase because rate also affected by pressure. High pressure, greater rate. But we want to check which one shift the equilibrium towards right. So increasing a pressure shift the equilibrium towards right, which will increase the yield. Increasing the particle size. If we increase the iron, rate of the reaction will be faster, but the yield will be same. The reaction reaches equilibrium in a short time. And increasing the particle size of a catalyst surface area, if you change catalyst surface area, it will affect the rate of a reaction, but not the yield. Yield is only affected by shifting of equilibrium, and shifting of equilibrium can only be done by concentration, temperature, or pressure. Is it clear, this one? Third, increases the rate. Does rate means no. Rate is different thing. Yield is different. Yield means amount of a product. Rate means speed of a reaction. When we use a catalyst, the reaction reaches equilibrium quickly, but it won't. We'll get the same amount of a product, but in a short time. Or we'll reach a equilibrium quickly if we are using a catalyst, but it won't affect amount of a product. Like for example, without a catalyst, it reaches equilibrium after 10 minutes. But with catalyst, it might reach equilibrium after 5 minutes. But amount of a product which was produced after 10 minutes or 5 minutes will be same. As catalyst does not alter the amount of a product, it only affects the speed of a reaction. Is it clear, this one?
Yes, sir.
Why does surface area of a catalyst affect the rate? Because what actually happened, catalysts have there are different types of catalysts. One is homogeneous, one other one is heterogeneous, but you're learning only heterogeneous catalysts. So how heterogeneous catalysts work? Heterogeneous catalysts trap the reactant molecules at the surface. Like it traps the nitrogen molecules at the surface, and when the hydrogen is passed over it, the reaction can occur quickly. Because like when they trap the reactant molecule on the surface, it reduces the bond strength. So if we use if we use a powdered catalyst, it will be more effective because a powdered catalyst will have large surface area. When it will have large surface area, it can trap more reactant particles on the surface. So the reaction can occur at a higher rate. So surface area of the catalyst and amount of a catalyst both affect the rate of a chemical reaction. But how catalysts work is not part of your syllabus. So you just have to understand the concept that increasing the amount of catalyst or increasing a surface of area of the catalyst, both will increase the rate of the chemical reaction. Is it clear, this concept? What is the advantage of manufacturing ethanol by fermentation? Fermentation is a slow process. And another method is there when alkene react with steam. Alkene plus steam is a fast process. And it will produce 100% yield, like only one product is there. Fermentation, two different products are there and you have to separate. So the process is very fast? No, the process is not very fast. Ethanol require no separation, that's also wrong because it does not give us 100% yield. So we'll have ethanol and water, so we have to use fraction distillation to separate. So we need a process of separation. The raw material used are renewable, that's the advantage of fermentation, that the raw material which we are using, we can grow them and it's a renewable raw material. There are no other product form, there is other product form, it will produce carbon dioxide as well. So this statement D is also wrong. So there are, like here it's written, there are no other product form. There is another product because glucose will produce, fermentation of a glucose produce ethanol plus carbon dioxide. So C will be the right answer. How in B is separated? Because what actually happened, you will never get 100% yield. Like example, you have a sugar solution and there is a yeast is there which is having enzymes which are biological. No, we don't. Carbon dioxide is a gas. When it is produced, carbon dioxide gas will escape. But the thing is that this will not be 100% ethanol. It will be like 30% ethanol is there and remaining 70% water, as it's a sugar solution. So you have to separate the water and ethanol from each other. Because the reaction as the amount or concentration of alcohol increase, the yeast killed off. So as a result, the rate of a reaction eventually, like it slowed down and eventually it will stop. So you will never get 100% ethanol. It's always like ethanol is there and some water which is there as a part of a sugar solution. So you have to separate them. It will never give 100% ethanol. So ethanol has to be separated from the sugar solution, or we can also say water. That's why fraction distillation is used for that. Is it clear, this one? Why in acid reaction with base or carbonate, we separate salt from crystallization? Why not distillation? It can be done, but the thing is that what's the use of using this in a distillation? If we need the water back, we can use distillation. It will work. Because we don't need that water, so we just allow it to escape. We don't use a condenser to condense that. Only difference between evaporation or condensation here, a distillation you mean, that in a distillation, we just condense the water back again into a liquid state. But not in evaporation, we just allow it to escape, or crystallization. Sometimes we need salt with water. Yeah, that's right. That's another thing, because sometimes we need salt with water or we need water of crystallization. So we cannot evaporate all of it. So we use crystallization. When bismuth 3 chloride BiCl3 react with water, a white precipitate is formed. So this is a white PPT. And the reaction is reversible. It is in equilibrium. Which changes cause the white precipitate to dissolve? If we add an acid, adding an acid means like increasing proton. If we add more protons, where the equilibrium will shift? Equilibrium will shift toward left hand side, because if I add product, equilibrium will shift backward. So as the equilibrium will shift backward, we'll get more aqueous. So adding an acid will dissolve that. That is one thing. So adding an acid will dissolve. So any option with one is right. Adding water. If we add water, like we are adding more water, so where the equilibrium will shift toward the right hand side. So as a result, we'll get more white precipitate. The precipitate won't dissolve. We'll get more white precipitate as the equilibrium is shifted towards the right hand side. In amount of precipitate will increase, not decrease. So any option with 2 is wrong. So B should be the right answer. If we add chloride, like sodium chloride, so sodium chloride means we are adding Na plus and Cl minus. So if we are adding more Cl, where the equilibrium will shift, it will shift toward the left hand side. So as it will shift toward the left hand side, the precipitate will dissolve. So B will be the right answer. Is it clear, this one? No, Cl, look, there is a difference here. This is BiCl, and here we have a chloride ions are there separated. So when we adding a sodium chloride solution, what sodium chloride solution contains? Sodium chloride solution contains Na plus and Cl minus ion. Like we are increasing the amount of chloride ion in the solution. That's why this causes equilibrium will shift towards the left hand side. And you can identify adding an acid was shifting towards left, adding water was shifting towards right. So that's why like any option with 1 is correct and 2 is incorrect. So even when you check the first 2, you will get the answer for this. Information about the solubility of the salts are there. Aqueous solution of which 2 compound produce a precipitate when added together. So what will the product here? Barium nitrate mixed with, so it will produce barium chloride plus calcium nitrate. All nitrates are soluble, so this will be aqueous, and barium chloride is also soluble, so aqueous, so this won't give a precipitate. When copper sulfate mixed with zinc nitrate, so it will produce copper nitrate and it will produce zinc sulfate. Most sulfates are soluble except barium and lead, so both will be soluble, aqueous and aqueous. When we mix sodium sulfate with potassium chloride, so it will give potassium sulfate plus sodium chloride. So most sulfates are soluble and most chlorides are also soluble except lead, silver. So this will be soluble. But when we mix lead nitrate with magnesium sulfate, so it will form lead sulfate, which is insoluble. The precipitate will be there, and magnesium nitrate, that will be soluble. So one is solid, another one will be aqueous. So D will be the right answer. Is it clear, this one? Calcium sulfate is also insoluble. So do we need to know about hydro? No, calcium sulfate is a soluble salt. You mean, okay, calcium, barium, calcium, and lead sulfate. Yeah, calcium sulfate is insoluble. That's right. To make a precipitate, one should be soluble and one should be insoluble. Calcium sulfate is also insoluble, but with reference to the question, it is not relevant to the question. That's why they did not give that. Even lead, silver chloride, lead chloride, mercury chloride, these are insoluble. And you should, yes, you should know about the solubility of hydroxides as well. It is there in the book. One table is there. Better learn that as well. Which statement about the trend shown in element of a period 3 is in the periodic table is not correct? Period 3. Element become less metallic across the period. When we move across the period, what happened to me? Like across here, we will find metals and here we will find non-metals. So elements become less metallic across the period. That's true, because like tendency, the group number increase across the period. So yeah, that's right. Group 1 is there, group 2 is there, group 3 is there. The number of electron shells increase across the period. The number of because the period represents the number of shells. So how the number of the shell remains same, it won't increase. So this statement is not correct. And number of outer electron increases. That's right. Like group 1 will have 1 electron. Group 2 will have 2 electrons. Group 3 will have 3 electrons and so on. So the number of the electrons across the period will increase, but not the number of the shells, because the period shows the number of the shells. If the element belongs to same period, they will have the same number of shells. Is it clear, this one?
Yes, sir.
The formula of two compounds of manganese are shown here, MnO2 and KMnO4. In these two compounds, the oxidation state of potassium is +1, oxidation state of oxygen is -2. What are the oxidation state of manganese in each compound? Look, first we'll work out for MnO2. They mentioned each oxygen is -2. So if each oxygen is -2, two oxygen will be -4, because there are two oxygen. So because the overall compound is neutral, so how overall compound can be neutral? So what should be the oxidation state of Mn? So Mn should be +4. Each Mn should have +4. So there's only one. So this one +4. Then in KMnO4, they mention each potassium is +1 and each oxygen is -2, but there are 4 oxygens, so it will be -8 total. So what should be the Mn oxidation state? Because the overall compound should be neutral, as there is no charge written on it, +1, -8. So how much it should be? It should be +7. Because like +1, +7 and -8 total sum will be 0. So Mn should be +7. That's why D will be the right answer. Is it clear, this one? Should I take whole valency when they ask for formula for the compound? Yes, you should take the whole valency. I'll give another example. Say you have a compound which is written Cr2O7. Okay. And the question is, what is the oxidation number of a chromium? Cr is chromium. Each oxygen is -2, so 7 oxygen will be -14. 7 oxygen is -14, so what should be the total here? It should be +14. So with reference to that, if you want to work out what should be the oxidation state, because two are having oxidation number of +14, so each one it should have +7. So in that case, it will be +7. But if I change the question, if I say we have CrO4, Cr2O7, and the charge on the Cr2O7 is -2, that's a charge on this molecule. Like it's not a molecule, it's a molecular ion. So now when we work out the valency, means the result should be -2. So each oxygen is -2, so 7 oxygen will be -14. So now what should be the chromium oxidation number? It should be +12 total, because the total result we need -2. So if two of them have +12, so each will be +6. So chromium will be +6. So it depends on the question that whether they give you a molecule. If they give you a molecule, the result should be 0. If they give you a molecular ion, then the result should not be 0. Like one more example related to this. If I say we want to work out the oxidation number of sulfur in sulfate. So sulfate is SO4 and the charge is -2. Each oxygen is -2, so 4 oxygen will be -8. So what should be the sulfur oxidation number here? Because the sulfate, the valency, the charge result is -2. So what should be the sulfur oxidation state? So it should be +6. Why +6? Because +6 and -8, the resultant valency is -2. Because it's a molecular ion, that's why the result is not 0. But what if I give you a compound? I say I have sulfur dioxide. Now what is the oxidation number of sulfur? Each oxygen is -2, so 2 will be -4. So sulfur should be +4. Why +4? Because there is no charge on the molecule. That's why the total valency of one element should be equal to the total valency of the second element. Is it clear, the two examples?
Yes, sir.
Can you give a more example where we can have an element that is more than 2? Yeah, like example H2SO4. So we have H2SO4 and we want to work out the valency of sulfur. Okay. So each oxygen is -2, so 4 oxygen will be -8. Result should be 0 because this is a molecule. Each hydrogen is +1, so 2 hydrogen should be +2. Now, what should be the oxidation number of sulfur?
6.
So it should be +6 because +2 + 6 makes +8 and -8, so result will be 0. Any other question from this? Hydroxides, I will share that with you. I will mention the solubility of hydroxides as well. The new edition of chemistry book is having that, so I will send you the picture for them about the solubilities of hydroxide